And so that's the advantage of performance-based design, when the uniqueness of the architecture or materials being used will still lead to the same level of safety as the base code provides. Then it should be our job as practicing engineers in the field of life safety, fire protection, but to make sure that those building owners can do the things that they want to do, can use their buildings the way they want to do, but doing it in a safe way. And that's what performance-based design allows us to do.
Well, hello, Bryan. Welcome to the firecodetech podcast. Thanks for coming on the show.
Thank you, Gus. My pleasure. Glad to be here.
Awesome. Well, I always like to get these things started with talking about how you found fire and life safety as a career path.
Well, my story's rather interesting. I'll give you the short version here because I can go on for a long time on this, but it's also one I think is fairly typical in fire protection. In that, while there are some people who know about fire protection early on, I didn't actually discover it until after I was already in college. I grew up in the San Francisco Bay Area. After my junior year, I have a twin brother, so him and I convinced our parents to take us on a 3-week 14-school tour where we hit schools throughout the entire country. That 3-week tour, though, was, let's say we flew in and out of Nashville and went everywhere from Florida to Massachusetts and through the Midwest and everything else. It was a very busy few weeks there. But I knew I wanted to do engineering because I enjoyed math and science. In my senior year in high school, I had an advanced chemistry elective where, well, so I'm previewing why fire protection is a good decision. My group, everything we did, because we got to choose our own experiments, every one of mine groups, except for one, involved stuff exploding or flames or something else. And another elective I had in high school that I started out and enjoyed was psychology. So what do you do with chemistry, fire, and psychology? Well, it was obvious then looking back that yes, fire protection, especially in life safety, was the route I was intended to go, but I had no idea it existed. We happened to stop at the University of Maryland because my brother he's the one who actually put Maryland on the list. He really wanted to see it because he was going into aerospace engineering, specifically astro. And there's some opportunities there that weren't available elsewhere. So he'd put it on the list. While we had agreed that neither one of us was going to make the other one decide where they had to go to school, we still ended up applying to a lot of the same schools. So Maryland, for me, adding it on was something of, well, this way, I mean, I did enjoy the campus, and if it was something that I wasn't necessarily a bad one and he really wanted to go there, so I put in an application. But we'd agreed we weren't going to decide based on what the other one did, and then found out about an opportunity I got at Maryland that I didn't have anywhere else, which was I got accepted into, which I didn't even know this program applied when I had even applied there, but they had what was called the Gemstone program, which was a 4-year interdisciplinary undergraduate team research project in science, technology, and society. And that really appealed to me, so it's okay, I'll go to Maryland. Still no clue that fire protection exists. I also knew I didn't know enough about the engineering field, so I went in undecided engineering. And I took my time to go and look around at the different majors. I knew I didn't want to do electrical or computer because that wasn't something that necessarily appealed to me, but okay, what's the difference in mechanical, civil, aerospace? And there's this fire protection one. Let me look at that as well. And as I started to look at it, some of the big selling points to me, obviously, as I said, I like fire, flames, and that chemistry class, psychology, it really fit. But one of the other big selling points on it to me, and this is something that's also true of our program at OSU, because Maryland's program was founded by an OSU alum. When I went to mechanical engineering to talk to them, it was as if I was a number. As I was just sitting there, the advisor said, what's the best way to put it? Later on, I was at an awards banquet a few years later. That advisor was handing out the awards for mechanical engineering and read off a name, and it was I guess he's not here. She then walked up. And so it was such I mean, I had the impression it was a number thing. And when one of your top students is getting awards, you don't even know if they're a male student or a female student. And he was the one who was advising everyone. And there was that you're just a number. Meanwhile, with fire protection, when I went there, I remember meeting with the program head on a Friday afternoon, and we had a conversation. Somewhat like this one here, where it was, well, let me know what you're interested in. Why were you considering this? Friday afternoon, I got there at like 4. We talked until about 6 o'clock. So the fact there's a faculty member willing to stay, talk to me about the program for a few hours on a Friday afternoon, and there's really that sense of family and community in fire protection, which is something that I thought, yes, this is a good fit for me. So the curriculum lines up, then, the atmosphere lines up, and that's how I got into fire protection. So a lot of sort of chances, if this hadn't happened, that hadn't happened, wouldn't be here. But I'm very glad that I found it because it is probably the perfect fit for me.
Man, some really neat stuff there in that first, just your background piece, talking about, your interest at an early age in chemistry
Mm-hmm.
and fire, and then how that, like that sense of family and in fire and life safety, which is something I've always seen people kind of band together because of the nature of it. And yeah, I didn't know that about the OK State being founded by a Maryland alum
Mm-hmm.
either. That
Well, no, other way around. Prof. Bryan, who founded the program at Maryland, graduated from OSU.
Oh, I didn't realize that. Wow. That's very interesting. Very
Yeah.
interesting. To give the listeners a little bit more context, would you speak a little bit about your professional roles and the kind of positions that you've held and how that work has colored your context now as a professor?
Yeah. So in this, I'll say one thing that I always encourage all of our students to do, and that's readily offered, is getting internships. So I'll start with some of the internships I had and how that sort of shaped some of my career decisions going forward. So first internship, it was right after I had decided I was going to do fire protection because that was my sophomore year. Summer after sophomore year, I had had one fire protection class at that point. So not too much in it, but was going to be home for the summer and wanted to have a meaningful experience. And from that, talked to Professor Milky at Maryland that spring of okay, I'm going home for this. I'm going to be home for spring break, then home for the summer. And I said before, I grew up in the San Francisco Bay Area, so the opposite coast of the country. And it was, so what options do we have out there? And he gave me contacts for 2 different alums that were in the Bay Area. I met with both of them over spring break. And then that led to a job offer from Jensen Hughes, or actually at the time it was just Hughes, because they had some major projects going on that summer where it was smoke control. I had never had a smoke control class, but they needed someone to climb up ladders and make sure dampers had closed, to go through and just do a lot of that type of work, which, okay, you don't need much in terms of classes and other things to be working on those projects. And because of how the schedule went in the month of July, I got 4 days off, Sunday the 1st, July 4th, although that one almost didn't happen, and then 2 of the other Sundays. And each day we were working, getting at the first job site about 9 a.m., leaving the last one about midnight, 1 a.m. Then I had to get home and rinse, cycle, repeat for the entire month. Now, I was being paid overtime for all those extra hours, so it was a very lucrative summer. But what I really took away from that one was just that value of the hands-on experience. Because never had smoke control, but when I took smoke control later on, I was like, okay, this makes a lot more sense because I've seen it, done it, and understand what things are. And even my classes today, I make sure when talk about smoke control, okay, when we're talking about the special inspector process, while I was there as the guy was doing it, so here's what people do when they do this, rather than just, well, I read about it in a book, but actually having that intimate knowledge there. I also, while in school, Spent a year, well, not quite a year, because it was supposed to start in the fall of the year when there was the anthrax scare in the Capitol. So my position got delayed starting a little bit because that same office was dealing with all of that. So they couldn't quite take on a student right at the start of the semester. But I was working with the Congressional Office of Compliance. And that was also a very eye opening experience because dealing with the Library of Congress buildings, dealing with congressional office buildings, I got to see an actual halon system while I was there, which is something that isn't very common. But there was a lot of understanding of from that sort of HJ perspective. How do you do things, especially in that environment where there's code compliance, but you can't make that building code compliant. So how do you have to sort of analyze the hazards? And while we weren't doing official performance-based design type of approach, it was that same process of understanding, okay, what are the hazards? What's the intent of the code? How can we make these buildings, a situation safe enough for people to be in the building? I was actually the first ever intern that they had hired. And it was a wonderful experience just to see it from that perspective. Other positions I've had before getting into academia, I spent a year working for Arup out of their San Francisco office, doing primarily life safety plan review, which again, that's a lot of okay, so how is it that you go about applying things to the real world? Plus, it also helps, I think, when I have students of, well, why are you giving us this? I had that assigned to me in my first 6 weeks on the job. You're going to be graduating soon. If they handed it to me, they can hand it to you. So let's get you ready for those things. And again, seeing sort of that overall hierarchy of how everything fits together and works together. And you have in that office a lot of different trades. Plus, also a lot of the work I was doing was more performance-based design. And so really diving into, again, that sort of, here's the intent of the code. How can we make sure that our building meets the intent of the code, even if we can't quite meet the letter of it? And then the other position I had before coming to OSU was working for the National Institute of Standards and Technology, NIST, in the fire research area. And that was a really meaningful experience in that I got to see just when you're trying to look at the problem, identifying, okay, doing research, identifying, okay, here's potential issues, was collecting data, here's what the data says, and being able to then bring that back into, because the National Standards Technology is the Department of Commerce, and so it's not just doing research for research's sake, it's, and now how is this going to be used to help improve things? And so that was a big learning experience there as well.
That's awesome. Well, I wanted to see how your interests in the more commercial side of things have influenced so what you research now. So that's very interesting. I like hearing about the performance-based design and the different, real world application. And, looking back at my time at OSU, I can see, some of the exercises that we did in our life safety class where we were really looking at the building code and functionally going through those. Now I do those every day, so I'm very thankful for that background. And when I got out into the workforce, I could really see how that set OK State grads apart from people who didn't, were just looking at the code for the first time. So I just wanted to, say thanks for that, and then I could see that in your teaching, and I resonate with that as you're speaking about it now. But yeah,
To add on to that, I'll just like to add that one thing that I've noticed happens, well, a lot in my career is that I try to bring that stuff into the classroom. I've had students many times write me like 6 months after they graduate of, yeah, when going through your class, I didn't understand why you expected us to know all this and do all of this. At the time, thought it was ridiculous. Again, they're 6 months in their job. Don't change because it turns out this is what my employer expects. When the students grumble about it, don't listen to them because what you're doing is a big service to them to help them getting ready for what the career world is rather than just the academic side of things.
Definitely, I think that there's a lot of great stuff in the. I had you for fire dynamics and the life safety course, and just I mean the fire protection engineering exam is very heavily weighted on the fire dynamics. It seems to me, and that's a great thing that we could talk about too. Is your recent experience in
Mm-hmm.
helping with the SFPE prep course, but not to get too far off track. But it just seems logical in the conversation topic, but
Yeah,
it's all kind of plays together. You know, you do it as a practicing engineer, or at least a lot of people involved with performance-based design do, and then it's also in the engineering exam. So all these things kind of dovetail education, experience, and professional licensure.
yeah. I'd say it's, as I said, they all dovetail together. People sometimes try to think about everything being separate, but in reality, everything's always interconnected and woven. You can't just focus in on one thing. It's always see, well, this ties into that, and here's how everything interconnects. And as you mentioned, yeah, I've been one of the things that I've done professionally is work with the SFPE PE exam prep course, which is something I very much enjoy because I think I'll probably talk a little bit more later about all my professional involvement, but I think it's very important. Oh, at least in my position, I realize how much the people before me have done to set it up so where we have the profession that we do. And I think it's very important to give back because I, and that was, again, this more later, but part of the reason I went to academia was the ability to give back to the profession, to have an even bigger impact than I could by just being a consulting engineer, for example, or working in an AHJ's office or whatever it is. Having the opportunity to give back because I realize how much others have given to me. And the P exam prep course is a good example of that because there are many, many people who go through that. And I will say the success rate of students who have taken that course, who've then gone on to pass rate's much, much higher than the overall pass rate. And it's a sizable percentage of people that are passing are basically taking that course because it does get into all the different topics. It's for those students who've been at OSU, you've already covered a lot of those topics in your classes. And same thing goes to people who might have a degree from Maryland or WPI or any of the other universities. But as we all know, that's not the majority of people in the field.
Yeah,
Most people are there because they've done a degree in something else. And those universities, while we would love to be having more students, it's getting people to know about it before they come to college or in their first few years. A lot of people don't discover the field until after they've graduated from college. And so for those people who might have been a mechanical engineer by nature, who so then they get hired by a firm that, oh, well, you can do air movement. So here, start doing this vent work for a smoke control system. Or, okay, you know, fluids and pipes here, you're going to be doing sprinklers. And so then they learn their one specific area, but not all of the others. And the area I've been teaching though for the P exam prep course, well, both on passive fire protection, which is one that, well, even a lot of people who've gone through some of those other programs in OSU don't have a deep knowledge base in, as well as the human behavior. And have helped with the means of egress one as well. So very much in just teaching people about, okay, here's what it means. And like I do in my classes, I tend to focus more on why things are the way they are in the codes and standards or how to approach problems and less on the sort of, well, here, memorize these rules. Um, the reason being is that, and I know a number of us who have taught for the P exam prep course, we've had this conversation, but is the intent of the course when you're teaching something like that just a get ready for the test, or is it about giving people the knowledge base they need to be successful in the field? And I will say on that one, while we are, I said, very good success rate and getting people ready for the exam, but there's also a lot of emphasis on not just here's the question, learn how to do these particular skills, and then you're done. It's really trying to make sure that the people who go through that have a better understanding of what it means to be a fire protection engineer, not just that they can do certain problems. Because there's other P exam prep courses out there that are much more of that. You just want to learn how to do problems, they'll do that. Um, but personally, I prefer the approach that SFPE has taken, which is why that's the one I've been working with, which is much more that holistic, let's tell you what you need to know. And in the process, you'll get better for the exam. But ultimately, I want people who graduate from OSU that have been in my classes or who take that P exam prep course or any other professional development course that I teach, is I want them to be able to go out and be a better professional. Not, well, I put in my time, got the checkbox, and so now it's time to move on.
I know what you mean. Yeah, that's a good point. I like the sentiment of understanding the deeper meaning why. The more I get into my professional career, the more I'm impressed by professionals that don't just can't aren't just regurgitating code, but they understand the deeper meaning and the intent and have the ability to push back when the official is not asking for something that is not within what the intent of the code what it's asking. And so I think that's very important. The more you get into the profession is to understand why and not just be a code jockey, somebody who could just is very lawyeristic. I mean, you have to be, but you need both.
Yeah, and I'll also add to that one, especially at OSU, which the reason why there I'm even more stressing why things are the way they are done is I like to point out to students of one, the codes are always changing. If you memorize, all you're doing is memorizing numbers or something like that, well, what if you know the, say, 2018 edition of the IBC, and then you're on the 21 edition of NFPA 101? What's going on in those two, especially from a life safety standpoint? The numbers change, gray areas might shift one way or the other, but what's going on there is no different. Let alone when we get to the 2033 edition of the code, I can guarantee you that there will be major differences from what there are now. Not necessarily sure what those are going to be, but we know that they're going to change over time. And if all that you ever do is memorize, okay, here's what this one particular section is right now, that doesn't give you the flexibility when you're going to the different editions of the code. Plus, let's say you get a project one time that's overseas. You have to meet their code, but you also have to consider from a life safety standpoint. And what's going on there, and are you actually meeting the intent? Because the intent of the codes, that's pretty much stable. We're not seeing that change one edition to the next. And so understanding those helps with performance-based design, helps when you end up in different jurisdictions. Yeah, ultimately it's going to make you a better professional if you understand why, rather than simply relying on the what.
Yeah, that's a good point. And you never know, whether you're going to be working on a Department of Defense job or a VA job or a FM, global criteria job where the criteria is going to shift so dramatically that, if you don't have your fundamentals rock solid, then you're just going to just be totally unwired in your capability to design or function in that space. So it's very important. Um,
Mm-hmm.
but yeah, so let's talk about your role now at OSU, and we've alluded to it several times already. But how you're a professor now, and a little bit of background on the program at OK State. Of course, go Pokes! I always like to promote the program when I get a chance to.
Oklahoma State University has the oldest still active fire protection program in the nation. So we've been around a long time, longer than any of the others. It was founded originally to teach some of the basics of fire protection. Then, as society changed and OSHA came into existence. The program added in the safety component. Now, we have some students who think it's fire protection or safety, but the faculty like to emphasize it's fire protection and safety. A lot of what gets done in the fire protection realm, in the safety realm, you're doing a lot of the same basic things. And so it's easy to transition from one to the other. They're not two distinct things. They're really, in both cases, you're trying to identify hazards, trying to identify mitigation strategies for those hazards. And then it just comes down to that specific application that you're applying it to. I will say the one thing that I think OSU does better than any of the other programs, I am biased here, but it's an engineering technology program. And engineering technology, what separates that is it's far more based on the hands-on. So in our program, majority of the classes that are in major have a lab component. So the students get to go actually touch, feel, experience, see what it is they're talking about. They're not just reading about it in a book. And I think that's a very valuable skill set to have. Going back to what I said earlier of learning about smoke control, being able to go into buildings and see those dampers operating and seeing how the special inspection was going helped me understand that far more than just reading about it in a book does. And so I think that's one of the big advantages to the OSU program is that hands-on applied part of the program and not just pure theory. Now, as far as what I've taught there, what I cover, I've just said it's not fire and safety. That being said, I tend to teach classes that are a little bit more fire focused because that's where I got my degree. That's also, I'm a professional fire protection. I'm a professional licensed fire protection engineer. So, yeah, that's my main area. But as far as that goes, my first semester at OSU, I was teaching sprinkler design, and at the time called Structural Design for Fire and Life Safety, where it covered passive fire protection and NFPA 101. Basically put the building code, passive fire protection, NFPA 101, and human behavior all into one course. We have since split that up some because it was that was too many important concepts all being crammed into one course. So taught there on passive, life safety, human behavior, and building code all at once. Then the next semester added in human factors, that's not fire protection, but is closely related to a lot of things I do, which is looking at human response in emergencies. And so it ties in very much directly with the research and, again, life safety side that I've been interested in. After that, because of some changes in faculty and other changes, I taught and continue to teach the suppression and detection course that covers, again, it's one of those classes we put probably too much in at first because it was the only class in the major on fire alarms, the only class in the major that covered special hazards, and covered the start of sprinkler systems all into one course. Now we've split off that special hazards more into an elective, which I teach. That's also available as a grad course. And that suppression detection class has shifted to being still the introduction to sprinkler systems, as well as much more on fire alarms and just how codes and standards operate and work. Then I also, as you mentioned earlier, taught fire dynamics for a few years as that was the best fit for who was on faculty at the time to be teaching that. I've taught smoke control. Yeah, so that's pretty much everything on the PE exam prep course, except for I haven't yet taught fluids because of just other faculty have gotten that one. But I've covered so much of what's on the PE exam, but I also think it's important for someone who's a professor to have taught that wide range because one, in order to understand, if you can you can teach something, you have to understand it. Um, and because if you're trying to teach and you don't understand it, it's going to be a failure for everyone at that point. And so having that is good. Plus, by having that breadth of course that I've taught, I mean, and you might remember this from some of the classes, but I'll routinely point out, and then in this class, here's how this ties together. And then in this class, oh, so bringing in those connections, which you know best when, okay, I've already taught that class. So, okay, well, in that class, you did this. Here's how that's relevant here. Because far too often, students, which they learn better than this when they get older, but students a lot of times view the class as okay, I have to learn this stuff for the test, and then I can immediately forget it and never have to know it again. And they don't see all those interconnections, but as many of your listeners probably know, as you get into a real profession, even if, oh, there's one area that you primarily work in, you don't just use the one class and that's it. You're having to pull in multiple things. Oh, all through it, everything's interconnected. And so by teaching all those things, it makes it even easier for me to point out to the students directly, okay, you covered that here. That's how this applies here. So if you need to go back and review what was there, this would be a good time to do it, to just tie in this entire experience of learning, rather than viewing it as a bunch of separate individual
Oh,
steps.
yeah. That's a great point because our profession is notorious for being just widespread. I mean, mechanical systems, electrical systems, life safety, and you're looking at building construction and passive fire protection. And so the whole profession is based on being a jack of all trades.
And I will say earlier I'd mentioned how I ended up in fire protection. The one part I meant to add in there as well is to just echo what you said, is one of the other things that 2 hour conversation with the program head, that drew me in was you had to be flexible. You have to pull in all these different things. Because just personally, I prefer having to, okay, I can use stuff from psychology, sociology, and human behavior. So you have to understand that. You have to understand the mechanical, civil aspect to a lot of other majors where you end up being much more siloed. You're not using as many different things. And that required breadth was something that definitely appealed to me, because it was, yes, there's more to this field, more opportunities, more career paths that are available than in some of the others.
It's definitely a good career for somebody who likes to be interested in varied pursuits and varied engineering systems because I mean there's just so many different things you could look at, especially I mean people get into product fire protection and UL listings and FM approvals. I mean, so you could be looking at fire and life safety characteristics about anything in the built environment and then also in the product market as well. So
And I would say that's also one of the big advantages to the OSU program, because it ties in, again, both fire protection and safety. We've had many alums that they start out going down one path and they go down something completely different and then go to something else because of what opportunities come up. And just having that OSU degree has opened up doors that a lot of the other people just didn't have available to them because of how special our program is and all the different things that it touches on. It really gives someone many different options for where they want their career to go.
that's a great point. Yeah, fire protection has awesome career opportunity, and I love that point also about that you said about the hands-on nature of the experience at Oklahoma State, because as a professional, you know everything looks good on paper, and so you can design something and think, oh yeah, it looks great, it meets all the code criteria. Well, it doesn't fit in the room, so you need to think about what does this physically look like, and so I think that's a very important distinction to make, that the physical and the corporeal manifestation of these fire and life safety features are just as important as their code compliance.
Mhm.
But so I wanted to break into a little bit of your expertise in evacuation and sort of your research topics. But I know that you have a big interest in these areas, and just I was reading some of your technical, one of the papers or pieces of work that you put out. I'm not as well versed in like how to analyze or read literature that's produced in academia, but I was trying and doing some research for the show. But I'd love to talk about just evacuation and what you're researching now and get into your professional expertise.
So, as before, I've taught everything, but and as far as, again, so that getting also I'll touch on that sort of breadth of knowledge of my senior research project was on passive fire protection, looking at the effect of missing spray applied material on a steel truss. My master's thesis was on characterizing the flow from a foam nozzle. Both of those were based on which projects are available, which projects have funding? Sure, I can do that. But good experiences, but for the PhD, I knew I needed to do something that was going to be what I enjoyed, because if you're going to torture yourself to go through that process of getting a PhD, which I've done it, and I still think anyone who does it is partially insane. There's no other real rational explanation there. But going through that, I knew it had to be something that I would enjoy, because if you're spending that many years that diving that deep on a topic, if it's not something that you truly have a passion about, it's not going to end up well.
Yeah.
And my passion, I knew, was in the area of human behavior and fire. Like I said, psychology in high school, tying that in, and also life safety. Why am I in this field? Ultimately, when I think about it, it's to help people. It's what I want to do. And not that designing a sprinkler system isn't helping people. It is, because you're keeping them safe when there's a fire. But looking at that human aspect, and understanding how people behave and respond, is something that was very much of a yes, this is something I need to be doing with my career. This is the avenue I want to go down. And so for my PhD, I spent a few years going through some stairwell building evacuations, basically going frame by frame, tracking what people were doing. Other people, again, going back to the insane part, thought that if I can sit there day after day going frame by frame, getting over 10,000 data points collected from this, um, let's just say they wouldn't have done it themselves. But again, going back to that hands-on part of it, what I found most valuable about that was going through that. I got a much better understanding and feel for what was going on there. Because if all that you have is numbers, okay, engineers, give me numbers, give me Excel or SPSS or SAS or one of those, and I can spit out stuff. I can get answers. But in the research field, one of the things that a lot of us, well, everyone knows is you can get numbers, but the job of the researcher is to understand what those numbers mean
Mm.
and to put them into practice. And so I mentioned this in my class a lot, but with human behavior and fire, pretty much everything that we discover and knew is not anything that is ever the wow, how is that true? I would never have expected that. It's always the yeah, that's how things are. But yet we've been designing not with that for
Mm.
years, and I'll get into some examples of that. Well, the first one I'll talk about, this is predates me, but one of the big myths in human behavior is the myth of panic, because there was actually for years and years and years it was you don't tell people what's going on in a building when there's a fire because they'll start to panic. panic's irrational antisocial behavior. Basically, someone starts standing there frozen in fear or shoving other people out of the way, and so on. And you can find lots of examples of this in Hollywood clips. Actually, one lab in life safety, I play a bunch of clips from TV and movies showing how they portray evacuation and fire, and then find clips on like YouTube of how it actually responds. In that, what do we see? The fire alarm goes off. If people get up, because it's just a drill, I can just ignore this. If they get up, they're walking orderly, patiently, letting other people pass them. Even when we look at case studies of real fires, same thing. So there was no reason to keep that information from people, but that's what the industry thought was everyone's going to panic. Or there's another example that, again, predates me, but this was one found by Prof. Bryan that, again, is not surprising. But early code development and requirements were based on everyone would just walk out the building, and that's basically a fluid particle, and that's how it would be. He came up with this, when he studied the Arundel Park fire, this revolutionary thing. Parents will go in after their children if they're left behind and they can't find them. Because parents went back in for their children in that burning building, or other people went in to rescue friends and other things, rather than just evacuating outside. And that was revolutionary at the time, but yet no one's also shocked that, wait, a parent would go after their kid? It's more the, wait, why would anyone think otherwise? But that's what the industry did at the time. So in my dissertation, one of the big findings I had there that has changed how we approach some things is, since I said I was looking at people evacuating downstairs, when you walk downstairs, you don't go straight, make a 90-degree turn, go across, make a 90-degree turn, and go down. It's more of an arc, a semicircle type shape around the landing. I even remember talking to my advisor about this, and it was are you sure? So then pulled up the videos, yep. And when I bring it up in class now, I'm yet to find a student of, no, I walk down and make those sharp angles. Okay, well, let me phrase that. I've then had students, when we did things on stairs, walk that way simply to prove a point, but it doesn't happen in real life. And so that's the thing. A lot of the studies in human behavior and fire is just pointing that out. I'll also say one thing I've done a number of talks and talk about human behavior and fire is mention, okay, imagine this scenario. You are sitting in an airport, a major metropolitan airport, one of those hub airports, and the fire alarm goes off. Oh, what are you going to do? And then play a video that's on YouTube of a fire at one of the major hub airports. And what does it show? And you can pull this up yourself from multiple different airports, multiple different places, and other things. What does it show? Everyone's sitting there. No one's trying to get back through security to have to cross back through. And every time I've talked to people, is that what you expect? All but basically one time have I had people say, yeah, that's what I expected. The one time was talking to a bunch of politicians, and they were shocked that not everyone listened to the directions. I guess politicians have a different perspective on things, but everyone else is yeah, that doesn't surprise me. That's what I'm used to. That's what I expect. The announcement comes on and people ignore it. And so that then gets into, and I've done research in this area as well, not just the movement, but also looking at how do we effectively get information to people? What is needed to get them to go from that just sitting there to actually starting to evacuate? And so how is it that the notification process works? Again, tying back into that human behavior and fire area.
That's very interesting. I definitely think politicians have a different view of reality, but that's off topic. But another thing I was just thinking about, and I didn't provide this before. This might be, I don't know if you'll have an answer for this, but I had a question about like performance-based design versus a more prescriptive design. And I know that the answer is probably it depends, but if you could give any insight to which one of these methods have greater allowances for life safety, or if there is a break even point in building size or complexity, where that might be.
You're right. The answer is it depends. It's actually it's difficult in that I don't think that there's a specific point of okay, when you get to this many square foot, this many dollar figure, whatever metric of sort of a cut and dry line. Because, for example, New Zealand at one point went to everything had to be performance based, and that did not work so well. But everything being prescriptive does not work well either. And really, if we look at, and I talk about this in life safety, so this is not really too far of a stretch for a question I sort of already know my answer in advance. And actually, I was talking about this just yesterday in class. When we look at the prescriptive code is in many ways a performance based code. And hear me out on this. When we look at the prescriptive code, where do numbers like maximum travel distance come from? Number of exits come from? Well, it's based on goals and objectives that get set. So NFPA 101, for example, is anyone not intimate with fire shall be kept safe long enough to evacuate, relocate, or defend in place. And so you can see that similarity to, okay, and you're doing performance-based design, you have to come up with your goals and objectives, and that's very easily one that's going to be there. Anyone not intimate with fire shall be kept safe. And then if we look at the code, theoretically, where did numbers like travel distance come from? Well, it's based on a typical building will have this type of fuel loading in it, and that's why it's different for each occupancy in part. So here's the expected fuel loading. Here's the expected ceiling height. Oh, therefore, the time until the smoke layer descends to where people are at should be about this much time. We know the speed people walk at. Put in a safety factor there. And so with this setup, everyone will be out safely before the fire becomes too big. Now, I say theoretically that's where it comes from because I think most of those numbers actually came from people at a conference room one time going, okay, we need to come up with a number. Okay, that one looks good. Let's use it there. But in theory, where it comes from is that. So like the occupant load factors, where do they come from? Going out, studying a building, counting the number of people, getting the dimensions, and adapting it for that. So the prescriptive code is very good for a building that's similar to that assumed building. And many of our buildings are. Because you're dealing with, okay, 7'6" to 10-foot ceiling heights, not going to be much different. The commodities in them are going to be about the same. People in them, we can start to come up with those methods to approximate what it's going to be. And as far as the having the committee then set what the minimum standard is, saves a lot of time and effort because if every project has to be performance based, that's a significant time investment for all the stakeholders involved. And for a simple 3-story office building where they're building 50 of them in the town type of thing, why go through each one of those projects and have to do that when the prescriptive code works very well for that? It saves time, effort, money. So for a simple building that's sort of meeting what that stereotypical building sort of underlying the prescriptive codes is, just do prescriptive.
I appreciate that.
A number of the numbers in the prescriptive code, I mentioned this in class yesterday, they're arbitrary. What I mean by that is, let's say I have 500 people in a room.
Yeah.
I can have 2 doors out of there, and it's perfectly acceptable by code, perfectly safe. I put in one more person, 0.2% change in the occupant load. That one person, I now have to put in a 3rd exit door. Have I really changed the safety in that building by changing the occupant load by 0.2% that I now have to put in a 3rd door? No, 501 people is going to be just as safe as 500. with 2 exits. There's not any study data or anything. 500 is a round number, and that's the number that got picked. Now, I'm not saying that 500 is a bad number. I'm saying it's an arbitrary number.
Yeah.
And that's the advantage to performance-based design. One project that I worked on while at Arup, there was a large casino that was being proposed to be built. And to make it work, they're going to have something like 12 or 13 stairs to meet travel distance requirements scattered throughout that floor. The owner did not like that idea. Why? For security reasons, putting in a lot of stair shafts makes dead spaces and security becomes a problem. Also, just the ambiance that they wanted there, so you can look across the room and see the person winning way over there. So that way you felt like you could be winning at your table. So they wanted that more open area. And travel distance is meaningful for a normal building. But let's think about, again, it's one of those major Las Vegas casino type places. You have a huge floor plan. So how long is it going to take the smoke to descend all the way down to where the people are at? And the answer was a very long time. I went through the fire modeling to determine what it was, but it was in excess of 20 minutes. And so then if we can get everyone out of there by just putting in, I think we ended up doing something like 4, 5, 6 stairs at the different outside of the building. It gets the owner what they want. And we're going to get everyone out of that building safely if there's a fire. I have no doubt about that in my mind. Why? Because that building's not a typical building. The wide open floor plan made it different. And ultimately, what's the goal of the fire protection community? It's to keep people safe in the event of a fire. So as long as we can keep people safe in the event of a fire, then, well, that's what matters. And so that's what we need to be able to show. And why prohibit the owner from doing something if it's going to be safe to do it? And so that's the advantage of performance-based design. When the uniqueness of the architecture or materials being used will still lead to the same level of safety as the base code provides, then it should be our job as practicing engineers in the field of life safety, fire protection, but to make sure that those building owners can do the things that they want to do, can use their buildings the way they want to do, but doing it in a safe way. And that's what performance-based design allows us to do. And so I'm not going to set a specific dollar figure or square footage or anything else, but if the prescriptive code does not meet the owner's desires, then the performance-based design becomes an option to be able to allow them to do what it is they want to do. And if they just want to go prescriptive because that's going to be a less expensive option, that's their choice. But if they have just that normal building and the prescriptive code works fine, then great. We've shown that it's safe enough.
Mm-hmm.
But for those unique designs, for those buildings where they want to do something a little bit different, then that's our job to make it so where they can accomplish their goals, but do it in a way that's safe.
I appreciate that. That's a perspective on performance-based design I don't think I've heard before. I don't have as much experience with it, but I appreciate that sentiment and how that discretion call and really understanding the factors of what safety level that the prescriptive code provides and matching that to calculated or performance-based design methods is very interesting. But anyways, well, I just want to wrap things up and say thank you for talking. Bryan, I could talk to you for another 2 hours probably. You've been just a wealth of knowledge on, and we didn't even get to speak about your professional society involvement more and your thoughts on the industry and where things are going. But I want to be mindful of what you got planned today, and maybe we can have you on in the future again to cover some of those topics.
Absolutely, I'd be happy to. It's great talking to you. And again, when you bring on a professor, I get paid to talk for a living, so I always enjoy talking about the industry of the field and doing everything we can to help promote it continue to see that growth.
Definitely. Well, I appreciate it. You make it easy on me, which I enjoy, of course. But alrighty, we'll wrap it up.
Thank you.
Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.